But now, if you look on the left-hand side, you get an exception to doing that. And the exception is when you work with a gas volume to a gas volume. You don't have to do step 1, 2, and 3, and then also this makes it possible for you to do even if you're not at STP, right? 22.4 is only true for STP, it's not true for the rest. So usually, if you read a question like this, what volume of ammonia gas, so ammonia gas, we're looking for volume, will be produced when 2.24 cube decimeters of nitrogen gas, so they give you volume of nitrogen gas, reacts completely with an excess of hydrogen gas. So usually you would have taken this one and made it into moles. Then mole to mole is a ratio. And then once you have moles, you would have gone back to volume. Right. And for volume, you would have had N equals Vm. So on this side, you would have divided by 22.4. And there, when you go back, you would have multiplied by 22.24, which would actually have cancelled out. Right. But what if it is not STP? If it's not STP, then that 22.4 is not true. But still, it will be the same amount that you will multiply and divide by. So when you look at what we call Avogadro's law, which you did last year, right? Avogadro's law. Avogadro's law tells you reagents in the same container, with other words, if they've got the same temperature and pressure. And there's no way that you can do a reaction where every single thing is not in the same container, right? So the fact that they're in the same container means they've got the same temperature and they've got the same pressure. And that means that the volume ratio is the same as the mole ratio. Now, I know you can't remember, but PV equals nRT, right? You don't have to do that this year, but just if they have the same temperature and pressure, so that one is already a constant, sorry. Let's make T is a constant and P is a constant. It's the same for both of it, everyone, no. And R is already a constant. Can you see what is the relationship between N and V? Directly proportional. So if you've got double the volume, you've got double the moles. So this actually, you don't have to remember that, but you have to know now that the mole ratio and the volume ratio is the same. So you get the mole ratio from your equation, 1, 2, 3, 1, 2, 3. But the moment that you have the mole ratio, that is also the volume ratio when you're working with gases. So now we're not going to make it into moles, do that. We're just going to work with the ratio. So for this one, you will say, let's look at this. What volume of ammonia gas? I'm looking for the volume of ammonia gas. Is produced when? Nitrogen gas. First thing, we're talking about volume of gas, volume of gas. And that is when I know I don't have to do everything. I can just go and say mole ratio 1 to 2, therefore volume ratio 1 to 2. I'm starting with 2.24. How much of that? Cross calculation. So it is just one step. You're not going to make it into moles first. Right. So you can do this at STP or not at STP, it doesn't matter. But if it's not STP, then 22.4 is not true, and this is the only way to do this. So if you turn over to the next page, page 30 actually, they say the following reaction takes place in a container, right, where, and there's the important thing, conditions are not STP. What does that tell you? Now the molar volume is not 22.4. It is not true. So you may not work with 22.4. Right. Now if you read this, calculate the volume of nitrogen dioxide. Wonderful. It is a gas volume. That will produce 4.86 cube that, and that is also a gas. So you're going from a volume of gas to a volume of gas. And this is my exception. When I know that, I know I go straight through. So N2O5 to NO2. What volume of nitrogen dioxide, so there the volume was asked, will be produced when a volume of 4,86 cube decimeters of this one react. Mole ratio is what? 2 to 4, or you can even write 1 to 2, right? So that is my mole ratio. But what do I know? They're in the same container, so it is also my volume ratio. The same. And therefore I can say if I start with N2O4 of 4,86, how much of the NO2 will be prepared? Cross calculation, and you end up with twice that, and that will be 7,52 cube decimeters of NO2. 7, sorry, 9, I changed the question and I didn't change the answer. 9,72, thanks, cubed decimeters. Everyone happy? When do I do this exception? When I'm going from gas volume to gas volume, right? With the previous questions, we went here from a gas volume to a solution volume. So the exception didn't apply. The second one, we went from mass to mass. The exception did not apply. Third one, we went from number of particles to gas volume. The exception did not apply. But now we're going from gas volume to gas volume. You're working with the exception, right? Do number 5, it's also one of the exceptions. Right, so once again, volume of gas to volume of gas. No. And that tells you we can just start by going straight through it with the ratio. Volume of ammonia gas is the one that they require, and they give us hydrogen gas 4,48 cube decimeters. So I will start by saying when we go from H2 to NH3, the mole ratio is 3 to 2, but that is also the volume ratio because they are all in the same container and it's all gas. And therefore I can say 4,48 to whatever, cross multiplication, and check my maths, 2,99. Yes, cube decimeters NH3. Right. Everyone happy? So remember the exception, because sometimes they ask this. You know, if there's an exception, obviously then it's a reason to ask things because it makes it a little bit more difficult. Right, over to the right-hand side. Now, yesterday when we did acids and bases, I told you we're not going to do titration calculations. Now, today we're going to look at that neutralization and calculations. Now, typically, they give us in a titration, where there's questions involve titration, where an acid neutralizes a base. Let's talk about that word neutralize. What do they mean when they say neutralize? It does not mean pH 7. Right. The one thing that it doesn't mean is it does not mean pH 7. What it does mean is they have reacted, the acid and base have reacted in the right ratio. They have fully reacted. Remember when we said it's a strong acid and a strong base are going to give you what pH? pH 7, right. But if you've got a strong acid and a weak base, you should end up with a pH that is less than 7, right? You should end up with acidic. So when they say neutralize, just focus your minds. Neutralize does not mean 7. A neutral solution is 7. But if an acid neutralizes a base in the question, eh? Okay, sorry, make that a 25 and make that a 35. See, there's a typing error. Did you see that one? Okay, let's reread. In a titration experiment, 25 of a 0.5 NaOH. So of the NaOH, They tells us 25 cube centimeters, and they give us the concentration, right? Neutralizers. What does neutralize tell me? Yes, they are in the right ratio. I can do it as I've been doing it before. They will react in the right ratio. And it neutralizes 35 cube centimeters of the sulfuric acid, and they ask us calculate the concentration. Right. So I've already done your planning. Right. They gave you this. You're going to firstly work out the moles. So you use concentration. What is the catch? Volume. What do we remember with volume? Volume have to be in cubed decimeters. Right. So remember to take it to cubed decimeters. And then you get the moles of NaOH. From NaOH, it should be a ratio, right? And then they don't ask the moles, they ask concentration. So this step 1, 2, 3, this is what we've been doing in the past, right? But when you do a lot of titrations, you get sort of lazy, hey? And that's why we now have a single equation that can do all of that. So actually this equation's got step 1, 2, 3. Step 1, where we work out the moles of the acid, there it is. You actually calculate C times V, hey? C times V, right? Then you work with the ratio. This is the ratio. It comes from my equation, 1 to 2. So this is my ratio. It comes from my equation, right? And then you say 0.5 times 25, and that is actually the last step. So can you see you do exactly the same. Now, if they ask me for the concentration, this is the fast way to do it. But because you do a lot of titrations and you do a lot of titration equations, they like to stop you somewhere along the way. Instead of asking you the concentration, they can ask you how many moles of H2SO4 were neutralized. So they can stop you over there. So don't forget, this is a one that you can do the long way around. It's only when they ask the concentration that you can do them all together. Right. So quickly, just an ordinary one down there to see if you find with neutralization and titration calculations. Where do you get the ratio? From the equation. So you have to be able to write the equation. So they're telling you sulfuric acid, and that's why we did acids and bases before moles. Right. So sulfuric acid neutralized by ammonia. Now usually when you have an acid and a base, it will produce salt and water. But what do we know about NH3? It's the one that does everything different. Huh? So it's not going to produce water as well. So sulfuric acid will donate hydrogens. And if it donates hydrogens, this becomes ammonia. So you will end up with ammonium sulfate, and you need 2 ammoniums for every sulfate, because the sulfate is -2. So you need 2 of the ammoniums, because that's only +1, right? So 2 of the +1s to cancel out 2 minuses, right? And if you can't do that, then you can't balance the equation. And if you can't balance the equation, then you can't do the calculation, right? Then go on and do the titration calculation. Right, so this is just quickly write down the equation, quickly write down the formula. Na over Nb equals CaVa over NbVb. Everything on your information sheet, you just get it from there. Right, start off, we need the ratio. It's acid to base. There's a 1 in front of the acid, and a 2 in front of the base, so it is 1 to 2. Right, so you get that out of your equation. What do they give you? Sulfuric acid. The acid, they give you the concentration 0.01. Is neutralized by ammonium if 20 cube decimeters of the base. So they give you the, concentration. Why don't you tell me? Right. So if 20 cubed centimeters of the base, so the base, you've got the volume of 20, is used to neutralize 30 of the acid, determine the concentration of the base. Now, why can I use just 30 and 20? Didn't I need to put that into cube decimeters? No, because it's at the top and at the bottom, right? It would have been times 10 to the minus 3 at the top and at the bottom, and that would have cancelled out in any case. So here, because you've got volume at the top and at the bottom, you don't need to go to cube decimeters. They will cancel out in any case. Right, and then hopefully you get 0.03 moles per cube decimeter. Right. Yes. Yes. Is there a way to do this without? No, because there's no way to know the ratio 1 to 2 if you don't write the equation, yeah. And that's what makes it difficult. It's easy to put it into the equation, right. The only thing is when you put it into the formula, just read very carefully. You know what I find when we mark this? When learners come to the titration question, they think, oh, this is easy. It's just putting it into the equation. And then they read too fast, and they put the volumes the wrong way around, or they put the concentrations the wrong way around. Don't, when you get into the paper and think this is an easy question, don't switch off your brain. Eh? Read carefully. Put it in the right place. If it's an easy question, don't lose the marks due to negligence and being in a hurry, right? Stay focused, stay focused.